In the first two sections of Chapter 3, we were introduced to inequalities and then started solving them with adding, subtracting. Now in 3 through, we're just going to solve those same inequalities, except now we can multiply or divide. So in that first box, we're missing some inequality signs off to the right. So what you want to do is add in the signs to compare those. If I take 4 and multiply it by 3, that's 12. So that's going to be greater than 1 multiplied by times 3. Same thing, 4 times 2 is going to be bigger than 1 times 2. 4 times 1 is going to be bigger than 1 times 1, sorry. But when I start multiplying negatives here, 4 times negative 1 is negative 4. That's actually less than 1 times negative 1, which is a negative 1. Same thing, negative 8 on the left is going to be less than negative 2 on the right. Negative 12 on the left is going to be less than negative 3 on the right. So we see that at some point we had a switch. We always had 4 on the left and 1 on the right. When we're multiplying by positive, we saw it was bigger on the left. When we multiply by negative, we saw it was bigger on the right. So what happened there? Problem above, we may have noticed that multiplying both sides of an inequality by a negative number affects that inequality symbol. So in this case, we saw that it just switched from greater than to less than. Just as we used multiplication division to solve equations in the last chapter, chapter 2, we can use that multiplication division to solve inequalities basically the same way. So we're going to name those properties similar. Again, multiplication property of inequality. We're just using to describe what I can do to that inequality in order to solve it for a variable. And let's talk about those variables again. If I just use a, b, and c, if I multiply with c being bigger than 0, so again, if I multiply by a positive, I see that if I start off with a being greater than b, if I multiply c on both sides, that'll still be true. I'll still have greater than. If I start off with a being less than b, and if I multiply c on both sides, it'll still be true. I'll still have a less than inequality. So again, at the top of the page, we saw it's the opposite when we multiply by a negative. So if c is less than 0, and we're multiplying by a negative, that means if I start off with a being greater than b, if I multiply times a negative on both sides, I'm actually going to flip that inequality sign. So greater than becomes less than. Same thing if I start off with less than, and if I multiply by a negative on both sides, I'm going to end up switching that less than sign to a greater than. And these properties are also going to be true if I use greater than or equal to or less than or equal to. It's not going to change my rules if I can still have those as equalities. So again, the top of the page is pretty helpful. I can see that when I multiply a number by a positive on both sides, I'm going to keep that sign the same. When I multiply by a negative on both sides, I'm actually going to flip that value. So let's see that with some practice on the next page. Next page, we start off with what's the solutions of c divided by 8 greater than 1/4. And we're going to graph those as well, just like we would on a test. So if I start off with division, same thing last time. If I want to isolate my variable, the opposite of division is just multiplying on both sides. So if I want to multiply 8, that'll cancel the 8 that I have on the left-hand side. And if I multiply on the right-hand side, 8 over 4 is going to simplify to just be 2 over 1. So I can leave the right-hand side as just 2. So remember, we do have to multiply on both sides. Don't want to just multiply the left and cancel it out. Multiplying on the right also will end up with 2 on the right. So again, since I multiply by positive, I want to keep that greater than sign the same, so I still end up with c is greater than 2. And if I want to graph, again, I just need a number line labeled with 1 point on the right and 1 point on the left of my solution. I know if c is greater than 2, I should leave an open circle and not fill that in, and greater than is going to head off to the right in that direction. Now if I want to use negative n over 3 less than negative 1, notice now that since my number is negative, we should be using our flipping rule. And a few people had trouble with this in the last chapter, but remember that if the entire fraction is negative, I can imagine either the top or the bottom is negative, but not both. So if I imagine that the 3 was negative, I can multiply by negative 3, and that should get rid of the negative sign also. So negative 3 going to cancel with division by negative 3. And again, that's still just using the same property. Opposite of division is still multiplying. And then on the right-hand side, we've got to be careful about the sign. Negative 1 times negative 3 is going to be a positive 3. Notice also that our answer, and if I say n is greater than 3, that's correct because we have to flip that sign. So again, since I multiply by a negative on both sides, a less than sign in the original question become a greater than sign when we had our final answer. So our final answer should be n is greater than 3. Again, graphing that same way, I put an open circle above 3, head off to the right because we should be greater than in that direction. And if I'm told to check that, we can check and make sure our rule still works with our negatives by trying again the endpoint and the direction of that symbol. So if I try the endpoint was at 3. So if I plug in 3 where the n was, negative 3 over 3 simplifies to negative 1. and -1 is not less than -1. So that's not a solution, but that's what we expected because we didn't fill in that circle. If I plug in a 0, so again, according to our graph, it should not be a solution. I don't see any arrow or I don't see any circle over it. 0, if I plug that in, I get 0 on the left, and that's not less than -1, so that's also not true. And on my number line, it's a 5, but yours could be really anything that's bigger than 3. As long as I substitute that value in, if I plug in my 5, -5/3 is indeed less than -1, so that is a solution. So that's a good way to check and make sure that our graph is headed in that right direction. So again, big rule to remember there, I think, with multiplication is just that if you multiply by a positive, you keep the sign the same, that's going to stay greater than. Multiply by a negative, that's going to flip the sign, so our less than becomes a greater than. So solving inequalities using multiplication is also similar to solving them using division, so kind of like what we saw with equations. If I divide each side of an inequality by a negative number, we also have to reverse that direction of the symbol. So same rules as with multiplication. So again, if I think of my number as being positive, if c is bigger than 0, if I start off with a being bigger than b, then if I divide by c on both sides, I'll still keep that greater than sign. And again, if a starts off less than b, dividing by c on both sides, it's going to stay less than if I'm dividing by a positive. But again, just like with multiplication, if I'm using a negative number to divide, if I take a divided by c, greater than becomes less than, so I'm going to flip that symbol. And again, if I divide both sides by c, but if I start off with less than, I'm going to switch that symbol to a greater than. So same rules. Again, less than is going to be the opposite of greater than. I'm going to flip the sign if it's a negative. And again, if I start off with less than, end up with greater than. So make sure that we're flipping with a negative, but not with a positive. And just like before, it doesn't matter if I have equal to or equal to. Still going to be the same rules in terms of your flipping. And next we're asked to try this with a word problem. So your family plans to buy food for a soup kitchen. A case of vegetables costs $10.68, which is going to end up being important. Your family has set aside at most $50 to use. What are the possible numbers your family can buy? And part of this question, after we define our variables, so let's just say x is standing in for the number of cases we can buy. At most 50 is important to set up our inequality because we have to know what that looks like. At most 50 should be a less than or equal to 50. And if you're trying to test that, again, if you want to think if I plug in a 60, 60 is not at most 50 because that's over that. At most means I can go underneath, I can be exactly 50, but I can't go over. So that's going to be less than or equal to. And again, if every case is 1068, I can just say 1068, multiply that by the number of cases I want to buy. And again, that should be less than or equal to 50 because that's at most. And again, to solve this, I just have to think the opposite of multiplication is division. So to get rid of that 1068, I divide it on both sides. And since we divided by a positive value, I'm going to keep that sign the same. Less than or equal to is still going to say less than or equal to. For our word problem though, since it's less than or equal to 4.7 cases, we're going to say that we can buy up to 4 cases for your family if we want to donate that to the soup kitchen. And we're answering why on the next step, why we didn't just say 4.7. We round to the nearest, not the nearest whole number, but the smaller whole number because we didn't have enough money to pay for that 5th case. We can't just round it up and buy 5 cases, because that would go over my dollar amount. Even if I'm closer to 5 than I am to 4, I won't have enough money for that last case, so I can't buy that. So again, in that specific example, we're actually rounding down instead of rounding 4.7 up like we would used to. So last question is also testing our rules for division, If I take negative 5x greater than negative 10 and want to solve and graph it, remember I have to get rid of multiplication still by dividing. So you want to make sure that we're not adding 5 to both sides. If it's negative 5x, that's still multiplication, so the opposite is divide negative 5 on both sides. But again, for our solution, since I was dividing by a negative, we should actually have the answer x is less than 2. Greater than became a less than because we divided by a negative value. And also you want to make sure of the sign on the right, negative 10 divided by negative 5, negative divided by negative is going to end up being positive 2, not negative 2. And just make sure to graph that solution by having at least 3 points on your number line. We want the solution, and we also want a point to the left and a point to the right. So again, since it's x is less than 2, I know that I'm going to start my circle at 2 and leave it open, and less than is going to head off to the left. So make sure you have these notes completed and come in ready for some practice.